In this video, I'm going to show you how to solve systems of two linear equations using substitution. So here's our first problem. Solve the following system of linear equations. 2x plus 3y equals 8, and 5x minus y equals 3. Now, we know how to solve a linear equation that has one variable, but these both have two variables, so how do we solve them? Well, the idea here is to use both of these equations to construct a new equation which just has one variable. Now the way we're going to do this is we're going to solve for one of the variables as an expression of the other, and then substitute that expression into the other equation, and that'll give us a single variable equation. So let's break that down into its steps. First, solve for one variable in terms of the other. That's the first thing we want to do. Now, what will be the easiest variable to solve for in these equations? I think looking at this minus y here, that just has a coefficient of -1. That's pretty easy to deal with. So why don't we just pull that second equation, 5x minus y equals 3, and then let's solve for y there. So we'll just subtract 5x from both sides, minus 5x minus 5x, and then the 5x minus 5x will cancel. We'll just have negative y equals 3 minus 5x. And now to get rid of that negative, we can just multiply both sides by -1. Multiply by -1, and the result is the negative cancels. We just get y, and then the negative gets applied to both of these terms, so -3, and then negative of a negative is a positive, so plus 5x. Now on to step 2. Step 2 is to substitute that expression into other equation and solve. Alright, so we're going to take this expression, this -3 plus 5x, and we're going to put that in for y in the other equation. So let's go ahead and write down that other equation. 2x plus 3y equals 8. And now we're going to take this expression here and put it in for y in this equation. So this will become 2x plus 3 times -3 plus 5x equals 8. And there we go. There's a single variable equation which we can now solve. So let's go ahead and solve it for x. So this becomes 2x, and then distribute the 3 to both of these terms. So 3 times -3 makes -9, and then 3 times 5x makes 15x, so plus 15x equals 8. And then combine like terms, so 2x plus 15x makes 17x. 17x minus 9 is equal to 8. Now let's just add 9 to both sides to cancel out that -9, and we just get 17x equals 17. Divide both sides by 17, and then we're done. So x equals 1. Well, that is to say we found one of the variables. We're done solving for one of the variables, but we still have to find the other. So let's circle that because that's important. But there's really still one more thing we have to do. Step 3 is to back substitute. And what that means is just to take that value that we solved, that x equals 1, and use that, substitute that into one of the equations to find the value of y. Why don't we actually just take this equation right here, this y equals -3 plus 5x, because that's already solved for y. So if we take y equals -3 plus 5x, and then we take that solution, and then we plug that into the x here, we can figure out what y is. So y just equals -3 plus 5 times 1, so y equals -3 plus 5, which means y equals 5 minus 3, which is just 2. So y equals 2. Now putting both of these solutions together, we have our final solution, which we can write as an ordered pair xy. The ordered pair, x is just 1, and then y is 2. And there we go. There is our final solution. We are completely done with this problem. Here's another problem. Want to solve this system of linear equations, a half x minus a fourth y is equal to 2, and then 2/3 x plus 3/4 y is equal to 1/2. Again, we'll use the process of substitution, but before we do that, why don't we clean up these equations a little bit? These equations look a little intimidating because they have fractions in them. Fractions are really tough to work with arithmetic and all, so why don't we try to write these equations again, but with no fractions? And to do that, we can just multiply each equation by something that will cancel all of the denominators of the fractions. Why don't we just take a look at this first fraction here? There's a denominator of 2 and there's a denominator 4. So we want to multiply by the least common denominator here, or the least common multiple of 2 and 4, which is just 4, because 2 and 4 both go into 4 as factors. So why don't we go ahead and multiply by 4 here, and then we'll get a result. A half of 4 is just 2, so 2x, then minus a fourth of 4, just 1, so minus 1y, is equal to 2 times 4, which is just 8. And now how about in this second equation? Let's multiply by something to cancel these denominators, 3, 4, and 2. What's the least common multiple of these? Well, maybe we can just think of counting by the biggest number, 4. It's not 4 because 3 doesn't go into 4. How about 8? Well, 3 doesn't go into 8 either. 12? Yeah, 3 goes into 12, 2 goes into 12, 4 goes into 12. It's got to be 12. So why don't we multiply by 12 here? And now, so multiplying by 12, 2/3 of 12, well, 1/3 of 12 is just 12 divided by 3, which is 4. So 2/3 of 12 is 8. So 8x, and then plus 3/4 times 12. Well, 1/4 of 12 is 3, so 3/4 of 12 is 9. So plus 9y is equal to a half times 12, which is just 6. And now we can proceed with the process of substitution. So first step in substitution, of course, is to solve for one of the variables in terms of the other. In other words, we want to isolate one of the variables. So first step, isolate. Now, what equation do we want to use to isolate what variable? Well, how about we isolate that minus 1y? Again, that just has an easy coefficient in front. Minus 1 is easy to deal with, so let's just choose that. So take 2x minus y is equal to 8. And then all we have to do is subtract off that 2x, so minus 2x on both sides. That cancels the 2x, we just have minus y is equal to 8 minus 2x. And then all we have to do is multiply by -1 to cancel that negative on the y. So multiply both sides by -1, and that result is that y is equal to -8 plus 2x. So now we're ready to move on to step 2. Step 2, of course, is to substitute. We want to take that expression that we found for y here and substitute it into the other equation. So we've already used that 2x minus y equation, so now let's use that 8x plus 9y equals 6 equation. And we'll take this expression that we found for y in terms of x, and then we'll plug that in for y here. We'll substitute it in. We get 8x plus 9 times -8 plus 2x, that quantity. That's all equal to 6. And here we go. We've got a single variable equation that we can solve for x. So let's go ahead and do that. 8x, and then 9 times -8 is -72, so 8x minus 72. Then 9 times 2 is 18, so plus 18x, that's equal to 6. Let's combine like terms. The 8x and the 18x is 26x, and then minus 72 is equal to 6. So add 72 to both sides to cancel out that minus 72, and we just have 26x is equal to 78. Now we can just divide by 26 on both sides to get rid of that in front of the x. We'll just get x alone, divide by 26, and 78 over 26. That seems kind of tough, but maybe we can simplify it just by thinking of an equivalent fraction. 78 over 26, if we divide top and bottom by 2, because they're both even, then we get 78 divided by 2, that's just 39, and then 26 divided by 2 is just 13. And 39 divided by 13, oh, that's just equal to 3. So x is equal to 3. So finally, we're ready for step 3, which is to back substitute. And we do that in order to find y. We know what x is, but we don't know what y is yet, but that's okay because we can figure out what y is by just substituting x into this equation here. So we'll bring that answer that we found, x equals 3, we'll take it back to this equation, y equals negative 8 plus 2x, and we'll bring that, put that in for the x here, so y equals negative 8 plus 2 times 3, and just evaluate. So y equals negative 8 plus 2 times 3 is 6, so y equals negative 2. So there we go, we know what x and y are, we can write our ordered pair. Our ordered pair is just 3, comma, negative 2. Here's the final problem. We want to convert the following system of linear equations to a system with integer coefficients, and then state the single variable equation obtained after substitution. Alright, so this is the system negative 0.03x minus 0.2y equals negative 1.7, also 0.001x plus 0.01y equals 0.09. Lots of decimals there, as we can see, and that's why we want to convert it to a system with integer coefficients to begin with. It's kind of like fractions. Fractions are tough to deal with, so are decimals, so let's just get rid of them and get a system with integer coefficients. Also, we're going to stop a bit early just after finding the single variable equation, because the rest of the solution will take a bit of time, but it's really straightforward from that point. Once you have the single variable equation, you just solve for that variable, and then back substitute it to find the value of the other variable. So, okay, let's proceed onward. So first of all, how can we get rid of these decimals here? Well, the key to getting rid of decimals is to multiply by something that'll move the decimal place. So we're going to end up multiplying by something. But what will that something be? Well, the question to ask here is how many times do we have to shift the decimal place? Now, in these two decimals, 0.2 and negative 1.7, we only need to shift the decimal one place, and that'll turn these into nice integers. But here, for 0.03, we need to shift it more than one time. We need to shift it twice because there are two numbers behind the decimal place. And now remember, to shift a decimal place one to the right, you have to multiply by 10. So since we need to shift twice here, we're going to multiply by 10 twice. So times 10 times 10, in other words, just times 100. You can also think of that like 100 is 1 followed by 2 zeros. The number of zeros here tells you how many times you're shifting the decimal place. Okay, so times 100, move the decimal place 2 places to the right. So this negative 0.03 becomes, move it over 1, 2, 3 point. So negative 3 point, or just negative 3x. And then minus, how about that 0.2? Move that over 2 to the right. Keep in mind that after the 2 come many zeros behind the decimal place. There's really a 0 after the 2, so when we shift the decimal place over 2 to the right, 1, 2, it's really 20 point. So minus 20y is equal to, well, same idea with this negative 1.7, that has zeros after the final number here. So when we move this decimal place twice, 1, 2, we get negative 170 point, so negative 170. Okay, so for the other equation, we're going to do the same idea. We're going to multiply something, but this time, how many numbers are behind the decimal place at most? Well, there's 2 here, but 3 here, 0, 0, 1, 3 numbers, so we have to multiply by a 1, 0, 0, 0. Put 3 zeros after the 1, that's multiplying by 1,000, but really that's just shifting the decimal place over 3 times. So this 0.001x becomes, well, this decimal place gets shifted 1, 2, 3, and we just have 1 point, so just 1x, so just x. And now for this 0.01y, remember that there's a 0 after the 1, so we move this decimal place over 1, 2, 3 times, and we get 10 point, so really plus 10y is equal to, same idea with the 0.09, there's a 0 after the 9, so we move the decimal place over 3 times, and we get to 90. So that's the right hand side here. And now we go ahead and begin with step 1 to isolate. We want to isolate one of these variables here. And it's probably easiest to do this for this x right here because there's no coefficient on it at all. So we can just take that equation, x plus 10y equals 90, and then just subtract that 10y over to the other side, and then that cancels here, cancels the 10y, and we just have x equals 90 minus 10y. Then we go on to step 2. Step 2, of course, is to substitute. So we want to take that expression that we found, substitute it in the other equation, which is negative 3x minus 20y equals negative 170. So we take this expression, put it in for x there, and we get negative 3 times 90 minus 10y minus 20y is equal to negative 170. And there we go, all we have is y as a variable, so that's our single variable equation. Now if we were to solve this, go through all the steps, we would get to y equals 10. And then if we back substituted, we'd get x is equal to negative 10. And you can check it for yourself that the solution is negative 10, 10. Awesome, so now we know how to solve systems of two linear equations using substitution. And in the future, we'll also learn another way to solve systems of linear equations, which is known as elimination.